Hello, everybody. This is Jerry Godero with Contex Scanners. Welcome. We're here for our webinar for our question and answer session for Ask the Scanner Experts. And what we'll do is we have a few questions that we included in our email blast about this webinar, so we can go ahead and use those questions. And if something comes up, you can just go ahead and ask us then. And of course, I'm here with Dan Bennett, our technical director, who is of course our great scanner expert. Welcome, Dan.
Hey, Jerry.
And we also have Doyle Cryer in the audience from our distributor, National AZON Equipment. Welcome, Doyle. And we also have Ted Stevens and a number of people, I think, from National AZON. And I know that Peter Boudreau from the Drafting Clinic Canada, his signal's a little spotty, but he's going to try and join us. And Peter may be able to also weigh in with some answers to any questions as well. But let's go ahead and get started. Let's see. So Dan, one of the questions was asking about how many pages per day can you scan with the IQ Flex large format flatbed scanner?
All right. So we spec that scanner 200 DPI RGB 24-bit color scans, if that's what you're doing, at 6 seconds per scan. The reality is I think the biggest bottleneck isn't going to be the speed of the scanner. It's going to be the paper handling. So how fast can the operator get a document out, set on the glass, scanned, and then removed and put the next one on? So at 6 seconds, realistically, really fast operator, let's say it took them 10 seconds to move the documents in and out, and that's probably being pretty liberal there, or being very conservative there, I should say. Let's say you can do 4 documents a minute. And then you can start doing the math. For 60 minutes in an hour, there's 240. Realistically, in an 8-hour day, I think most operators could handle somewhere between 1,500 and say 2,000. Really strong operator with a bunch of documents that have been staged and everything's perfect. It's a lot to ask for a human being to be that much on their game.
Sure.
When they're moving documents in and out. But the bottom line is the scanner is really fast. At 6 seconds per document, it's really moving along.
So it really comes to how you have your documents stored and able to get them onto the scanner and back off of the scanner safely as well, to make sure you're not damaging anything, and how fast it can be done.
Yeah. So the bottom line to the answer to that is this is really one of those things that it's difficult to answer because every operator is different. And it really is what you're comfortable and what kind of demands you're putting on yourself too.
And I know somebody that's an expert at this type of thing, the return on investment and how much you can get in and out of a scanner. That's definitely our friends at National AZON. And Doyle Cryer, I know, has almost like a calculation, a computer program, a spreadsheet set up to plug in certain numbers, and with variables like that, how many breaks a person might take, even how many turns, I think, and in getting their scans, and then how that equates to hours in the day of scanning and how many.
Right. They've really done a lot of studies on just the mechanics of paper handling, especially with the other roll-fed scanners. And so, yeah, reach out to Doyle, and I'm sure he can probably give you much better data in a real life situation, because what we spec and what the scanner can do is obviously quite different than the real world. And that's, you got to move the paper.
And you were mentioning that they've done a lot of those studies, and all those studies, I think, are focused on, because National AZON has come out with their zero turn productivity system, and that's more focused on the sheet fed, the roller fed, our traditional large format scanners. But that zero turn system also will save 300% in scanning time, is what they've done the calculation out to.
Yeah, it's pretty incredible.
Yeah, it's a pretty neat piece. And it's a great addition to a Contex Large format.
It's all about the number of touches for the operator. The scanner doesn't work very long when it's doing 1,000 scans at 6 seconds per scan. That's a minimum amount of work, so the humans just got to keep up.
Yeah.
Yeah, and with that said as well, the Flex is a little different because it is a flatbed scanner, and we don't have the same paper sensors and that type of thing that you would have with a wide format roll-fed scanner. So we have a feature called batch scanning that if you had a regular scanner, a regular roll-fed scanner, every time you put a document in, it informs Nextimage or scanning software that a document is loaded, and when it's ready, it will automatically take it and then eject it out the back. That throughput gets to be really fast. And so we have some pretty nice tools to try to do, as Doyle said, have the operator touch it as few times as possible. So for example, creating a file name, it can be done automatically within the batch. Automatic take up and exit, those types of things are all done very automated. So now the operator is really focused on touching the paper, getting it loaded in the scanner and going without touching with few buttons as possible. So
just limit that interaction and just keep things moving as automated as possible. And then we also have another question is about our Nextimage software, and is asking, does Nextimage have stitching capabilities?
All right, so that's an interesting question, because it depends on the scanner, and it depends on what you're defining as stitching, because we use stitching in calibration to stitch multiple cameras together. But I think what really the question was geared around is, can you take, if I understand it correctly, can you take multiple scanned images and then will Nextimage stitch them together? And so the answer for that on a typical scanner, roll-fed scanner, would be no. However, we do have another feature within, for example, the IQ Flex, the flatbed. Because it is a flatbed, we do allow you to do something called oversize scanning. So you can go to the next sheet size up and scan that sheet multiple times. It has you, a little wizard starts, and it will have you scan it and then scan it again to get the entire image. And then it auto stitches those multiple passes into one image. So the short answer is yes, it stitches, and no, it doesn't stitch. And yes, it also stitches because of calibration. So it's a little confusing on exactly what you're defining as
stitching. But so it does stitch in a specific instance when used with the large format IQ Flex flatbed scanner, but not maybe in the way that the question was posed with our sheet fed scanners producing multiple images and then giving you the ability, maybe in a Photoshop sort of a fashion,
right,
to do
that would
stitch.
Be the best comparison. Yeah, if you got Photoshop or CS or something like that, where it can take multiple images and find a stitch point and merge those together. Right. No, Nextimage.
And I know we've worked with some software in the past, like with the consistent software, their Wise Image, and that allows for very nice stitching for large format images. And that typically involves things like maps and things where you have a grid pattern or you have a topographic pattern, and you can simply take an image and do really almost like a 2-point stitch with their software, where it allowed you to match one single point. And then as you rotate it in the second point, it actually did a scaling at the same time. So if the drawings were slightly different sized, it would match that second point and scale all at once. And that feature is great for large format, but that's not what we're going to find in Nextimage. That's going to be a post process, certainly, just like Photoshop would be.
Yeah, Nextimage, we really focus to the input side, the scanning side. And there's some really great tools out there to do a lot of amazing things.
Sure.
And we leave that up to the third-party developers to be doing.
And I think we get a question a lot about going ahead and running the Contex scanner with that application that they might be using, like Photoshop or something like that. And we almost always say the best image possible you're going to get out of a Contex large format is going to be using the Nextimage software to get that large format image. And with some of our scanners, even as much as a raw 48-bit color file, and then take that file into anything else you want and do all the manipulation that you want with it.
Yeah, we're very big on productivity tools, and Nextimage is really designed around productivity and being able to do repetitive tasks as quickly and as efficiently as possible. And so we really heavily focus down that path and stay out of a lot of the post-processing abilities of other software developers that have already basically done it for us.
And then let's see. And I think we answered, Dave Gainey was asking just one sticks with the IQ Flex. I think we answered that. And then, so Michael was saying, Dan, what was the name of that particular menu option within Nextimage that can allow a stitch for the IQ Flex?
It's called oversize scanning. So if you, on the IQ Flex, if you desire to scan something larger, as soon as you go above A2, it will automatically put it into the auto size wizard will start. And basically what it does is it has you scan, and you can't go, for example, you couldn't put a 60-inch document in and have it function. It basically is going all the way up to, allows you to scan a D size document. So 24 by 36, even though the flatbed is 18 by 24.
18 by 24 C size. And so I think just like you were saying, when you put in a specific, the A2 size, that, but also as soon as you dial in on in the Nextimage, the width and length, anything wider than 18 by 24 up to 24 by 36, I think it automatically also kicks in that oversized wizard, right?
Right. Yeah. Yep.
Okay.
Yeah. And on if you were running the IQ Flex within the internal controller, so directly out of the scanner and not using Nextimage, it works the same way. When you go, you can pick a D size, and then this other set of menu options will appear, and it'll tell you position the sheet 90 degrees in the scanner such like this, and it gives you a graphical image of how it looks, and then have you rotate or push it out the back side of the scanner. I can't recall any longer exactly what the combination is, but it'll take the second pass to get the rest of the data, and then it auto stitches it, shows you a result of it. If you're happy with it, you just click save and you're off and going.
Gotcha. And I think, so we'll go ahead and we'll move on to our next question, which is, I think, got to be your favorite question, which is, what is the number one enemy of all scanners?
Which funny, because you say that, you know exactly what I'm going to.
I think your answer is the same as the answer for the James Webb and the Hubble Space Telescope and anything else with optics.
This subject often gets brought up in just about every one of these Q&As that we have. I would say number one enemy is dirt. The scanners are so incredibly, what's the word I'm looking for? So sensitive. They have this ability to see everything. And that's a very positive attribute if you're trying to recreate an image as true as possible. The caveat to that is, as glass becomes dirty, stuff gets brought into the scanner by these filthy documents that we scan, the dirt will start to show up in your images. And that's something that most people find unattractive. And so the key is dirt. The good news is with dirt is it's just a matter of cleaning. And so you have to do your due diligence, and depending on what it is that you're scanning, that will determine how often you need to clean. And it's not a monumental task of when we're speaking to cleaning. It's basically flipping the lid of the scanner open up, swiping the glass off, because most of the dirt that's going to get brought into the scanner is probably small little grit particles and whatnot, silica and that type of thing, dust that sticks to the glass, and then it shows up in the image as a line. And to remove that, you don't need to recalibrate or those types of things on that day-to-day type of dirt. Just, we include a lint-free microfiber cloth with the scanner when it's new. That thing's amazing to be able to grab a hold of all the dirt that's on the glass and pull it off. We always recommend one good swipe at the very end after you've cleaned everything, one good swipe from right to left or left to drag all the dirt away, and maybe even wipe the bed of the scanner off.
Yeah, because I think people are thinking that they get in there and they go back and forth cleaning a car window or something like that, and that just reintroduces a lot of kind of floating dust particles potentially right back in.
Yeah, and it moves it around and whatnot. And
that single swipe really cleans the slate.
Yeah, the objective is to get it away from the optic area of the scanner, and that is where the glass is. One other thing with cleaning as well is often people will look at a glass plate and go, wow, that's just really clean. But you have to remember, these scanners are 1200 optical res. It's not looking at the entire glass plate. The scanner is only seeing a 1200th of an inch scan line
right down the middle
of that glass plate. And so when you're looking for things, you got to start thinking in terms of, if it's a 1200th of an inch in diameter and it happens to be right where the scan line is, it's going to show up. So just don't take a quick glance at it and say, oh yeah, it's perfect. But the bottom line is you should be able to clean the glass in just a few seconds. It doesn't take very long at all. And if you get into that regiment of maybe it's every 10 documents or something, flip it open, wipe it, close it, keep going, that'll really go a long ways. But dirt is number one enemy.
And I think, like you're saying, if you just know it's part of your process, and that's kind of part of Doyle's figuring out all the time. If cleaning it is part of it, sometimes even cleaning the documents a little bit, because they just can come in so dusty depending on how they were stored.
I would say number two enemy is probably Scotch tape. Scotch tape, it's got that gluey tack to it, and that stuff has a tendency, the glue wants to rub itself off on the glass, and that is a little
very
bit harder
old,
to
and
get
then
off.
it's years later, that's when they're being scanned.
Yeah, Windex is great for getting that glue off, isopropyl alcohol, that type of thing. So you may have to do a little harder work if you're fighting, where you've had tape and someone's removed the tape and now you got a big tape area where it's just really tacky. That stuff has a tendency to want to stick to glass. So
Dan, let me put in dried rubber bands, melted rubber bands right up there with the Scotch tape, because they do about the same thing. But I always seem to come up with problems for Contex to look at, but I will pass out a compliment here. The last 4 or 5 service bureaus that I've been in with the X models, where the design has been changed on the feed bed to have the little grooves in front of the glass, we have seen an amazing amount of lint and things off the documents that have been caught before they go through the scanners. And in addition to that, we have found things like really small pieces, staples that are broken off inside rolls and that type of thing. And it's really done a lot to cut down on the glass cleaning. The folks that have been using Contex for years are really raving about the design.
that's good to hear, Doyle. That's good. Yeah, I don't want to harp too much on cleaning, but Rain-X, that's another great product for car windshields, that type of thing. You apply a little Rain-X to the surface of glass, it dries fairly quickly, and then you buff that off. Rain-X has a tendency to put a coating on the glass that kind of fills in the microscopic pores of glass. And then the reality is, the document is the source of all the contaminants. That documents build static and everything clings to them, and then it gets rubbed off onto the glass. If you have the silicone coating type material that comes with Rain-X, it basically fills in all of the pores and whatnot that you can't see in glass that are there, and it basically just helps keep the grit particles traveling through the scanner and not deciding to stop right where our scan lines are. And so Rain-X is a pretty nice product to use just in a regular, maybe you do it every couple days or whatnot. And it really depends on the volume that you're scanning, and what it is you're scanning.
Gotcha. And it looks like Phil Hassel was weighing in on a little bit on our last question in an answer to Dave Gainey's question about the IQ Flex would be a single stitch. And so Phil was saying it's 3 arrays. So the IQ Flex, so it would be 2 stitches. So he's probably correcting us there.
Okay. Now I need to be careful because we're talking about 2 separate things. And that's what I mentioned in the beginning. Stitching is the technical term that we use in R&D for joining multiple cameras into one single scan line. And so in calibration, we have a utility that will take and analyze where 2 cameras come together or 2 CIS modules come together, and we will stitch those 2 arrays together into a single line. On the IQ Flex, there's actually 3, and that's what Phil was alluding to. I think, and we do the same thing with the roll-fed scanners. I think what this question was really targeting was, do we have a utility within Nextimage that can take multiple scanned documents and merge them together or stitch them together? It's a term that a lot of people use. I don't really like it because it gets confusing for people to try to get their head around. Are we talking about a calibration stitch, or are we talking about merging two documents into one document, into one bigger image? And so, yeah,
it's just a little misunderstanding on how we're referring to stitching with the cameras and the sensors in the Contex Large format, and what most people would be thinking about stitching an image together, which we took the question, we don't have that capability to, and we segued it into a nice thing about camera alignment and things like that. So I think we did.
Yeah, so it can be confusing. And if they're not familiar with the terminology, it gets really confusing. What exactly are we talking about?
Here's one that I've seen here and there, and it is asking about, how can I add cybersecurity to my scanned images?
Okay, that's timely. That's a timely question, actually, because Nextimage doesn't necessarily have any data security protocols built into it per se. We utilize whatever Windows or whatever environment that your network security is geared around. However, we just promoted recently a utility called PaperVision Folder Monitor, and it's provided by a company called Digitech Systems. And this is a collaboration that they did with Contex. And so if you have an organization that has to adhere to specific like data security protocols, what this utility will do is, as you're scanning images or your batch scanning images, it will monitor all of those scanned images and basically sweep them all into their PaperVision. They have basically two suites of that. They have PaperVision Enterprise, which is an on-premise solution, and then they also have something called Image Silo, which is a cloud solution. But basically what it will do is it'll sweep all of these scanned images into those applications and embed all of the data security protocols that are typically used. So we're not doing it specifically ourselves. Again, this is another one of those things where we target Nextimage about scanning images and doing it the best, most efficient way possible. And then we rely on some of these third-party vendors out there that are experts in their field, for example, with data management, that type of thing, and let them do that. But they have a utility that's been specifically developed around watching a Nextimage folder that is scanning images and then grabbing them and sweeping them into their utility. So if you want more information on that, Digitech Systems, if you do a web search on PaperVision, you'll find them real fast. So hopefully that answered that.
Yeah, I bet it does. And then so our next question is saying, sometimes our IQ Quattro X backs up the feed sheet, and they're asking why this is.
So you're scanning an original and then it stops, backs up a little bit, and then
I think that's what they're saying, like almost like memory buffering backup kind of thing.
Yeah. So the reason that happens is if typically the scanner is going to be faster than most computers. And if you exceed the buffering or the buffers within a PC, then we will stop the scan, wait for the PC to catch up, and then we'll take off again. The reason it backs up a little bit is, again, it depends on which scanner that you're utilizing. But we back up a little bit so that when we start moving the document again, it is up to full speed when it reaches the last scan line that we captured. And that we do that in an effort to reduce what we would call in the technical world something called start-stop jitter.
So it's like a running start to a race rather than just right at the finish starting line.
That's, I guess, a great way to put it. Yep, absolutely. So yeah, that you're exceeding the buffers, and so we have to stop the scan and wait for it to catch up.
And in particular, on that scanner could be running at 18 inches a second. And
with Quattro X, it's
18
or 14. I don't know.
The X brings it up.
The X, yeah.
18.9 to 17.6, I believe. So almost 18 inches a second.
Yeah, we have a pretty significantly large buffer in the X scanners. HD Ultra X and the IQ Quattro X. But even with those really large buffers, we can get ahead of the PC, especially when you're scanning higher resolution type scans. If you're staying low, typically we can almost scan the entire document straight into our buffer and then pass it off to the computer while you're, it's not so easy to do if you're scanning something at a real high resolution, because there's just too much data to process within a single buffer.
And we've got another question from Dave Gainey. So Dave is asking on another subject. In your words, what is the best way to promote / inform regarding the black channel that we have versus competition that doesn't have a black channel? How do you convey that?
Okay, that was Dave Gainey?
Yes.
Great question. So we, in all of our CCD-based scanners, we use a quad linear CCD. I'll try not to get too technical here. And what that means is you have 4 channels of data capture in each feed. We have a red channel, a green channel, and a blue channel, and we use those 3 channels in combination to create 24-bit color. So when we're color scanning, we're always using the RGB channels. But then we have an additional channel called the panchromatic channel, and we use specifically just that single channel for scanning in gray tone or black and white images. We do it for twofold reasons. Number one, it's a dedicated panchromatic channel, so it's most optimum in looking and analyzing gray tone images. And what some of the competitors have done in the past is they'll maybe take the green channel of the RGB channels. They'll take just the green channel and they'll use it to capture gray data. And it just doesn't work nearly as well when you have a channel optimized for gray. The other advantage that it gives us is we're able to parallel process all the information on the black and white channel, which means basically we're going to take all the odd pixels and process them simultaneously as we're doing all the even pixels. So meaning pixel 1 would be an odd, pixel 2 is an even. We split those and we can parallel process, which means we can do this really fast and really efficiently. So that's the technical background to why we have, or what we do to capture gray data. So we have a special chip that has 4 separate arrays.
So I'm going to go out on a limb and go way the other direction with how to say it. Talking about competition in the most basic way that a lot of people can really understand this. And it's not even comparing quite the same industry, but when you have these printers that have only color cartridges in them, and you're asking those color cartridges to also do your black, rather than having a printer that also has all your color as well as a dedicated black cartridge. So you have something you have that 4th channel that's working and giving you a better overall image, a better overall product, because you have the dedicated colors and you have the monochrome, the black and white.
Yeah.
Does that anyway match up?
Yeah, so here's probably a more elegant way of putting what I just
I was trying to go
previously.
way simplified there, sorry.
So basically the quad linear CCD has exactly the same 4 arrays. However, in the color area, for example, the red channel, what we've done is we've applied a filter that filters out all of the green and the blue. Actually, basically, it filters everything out other than the red color spectrum that is allowed to get to the sensor. So the panchromatic is basically unfiltered. It's just seeing everything. Where if you were trying to use a green channel, you're trying to capture gray data, but it's being filtered. It's filtering out all the red and the blue data. So it just is not a very good tool to capture. If you want gray data, you want gray data. And again, so we can offer you the full 16 bits of gray tone data coming off of an unfiltered.
And I think in the way that Dave's asking it and how you would put it out is that because we offer this dedicated black channel and some other scanners don't. This is an advantage that you would have, or also potentially a more accurate scanner that you have in purchasing with the content.
Exactly. This is why sometimes a technical guy isn't the best to answer
Well,
some of those questions, because we're going to get to.
Maybe that's why they like to record us together.
It's the balance.
And then,
Dan,
yes, Doyle, go ahead.
Going away from the quad linear CCDs for a second and just talking about the practical side of this thing, one of the biggest mistakes that we see, or one of the least optimized things that we see, is when we see a Quattro scanner that's been in the field and people are scanning with it, but it's been connected via USB 2. Then we go in occasionally and see a Quattro X that's been connected via an Ethernet connection. Can you address the transfer speeds between USB 2, the Ethernet, and USB 3, and what should be hooked up for each of those scanners?
Yeah. Okay. So I'd have to, I don't know if my memory is good enough anymore to remember exactly what the throughput is on USB 2 versus 3, but it's 400 megabit per second, if I remember right, on USB 3. Maybe I'm wrong on that. Maybe it's a full gig.
245 on USB 3. USB 2 was 31.
All right, there you go. So just doing the math there, you're getting a dramatic increase in speed over USB 2 and 3. Unfortunately, most PCs, they add the little blue plug in so that you can tell you're plugged into a USB 3 connection. But honestly, a lot of people miss that. It's become much more mainstream today than it used to be. But and most PCs are supporting USB 3. But like Doyle said, it's amazing how many people just miss that and wonder why the scanner's running slow, and they find out that you're attached to a USB connection and it's really slowed the whole scan process down. You're not seeing the throughput that you would normally see. So pay attention to that. The other difference is back in the older days when we only had scanners with USB 2 connections, we also had gigabit Ethernet along with that connection. And to get the best throughput, you were better off going with an Ethernet connection than you were with a USB 2 connection. That now is not the case with the new scanners, such as the Ultra X and the IQ X. The reason being is USB 3, its data transfer rate has exceeded gigabit Ethernet. And so to get the full speeds of the scanner, USB 3 is how you want to connect it. There's, of course, a lot of great advantages to Ethernet, cable lengths and ease of access across the broad network. So there's a lot of good reasons why you might want to run Ethernet. And it's still honestly my preferred interface just because of that reason. But when it comes down to, I just want to see the fastest scanning possible, go back to USB 3. Did that answer your question, Doyle, or your statement?
It does. The one thing that I would add where the USB 3 has been just a complete game changer is when we see people scanning above 300 DPI, the transfer speeds on those larger files, it is noticeably different between the Ethernet capability, which is 110 megabits per second, versus the 245 on the USB 3. High-res files, it's a huge difference with USB 3.
Yeah.
That's a great.
We do some dynamic adjustments to the bandwidth based on the computer that we're dealing with. So we do monitor that. And again, we don't want to get too technical here, but if we see the throughput of the computer really bottlenecking the scan speeds, we can throttle back the speed of the scanner a little bit. It's not really applicable so much in today's world with the newest scanners, because again, we put such large buffers in it that in a typical standard scan that most people are doing, you're literally getting the entire document into the buffer and done. And it's when you start to, if you had a real issue where you had a lot of start and stop, you'll start to see the scanner slow itself down to match the input buffers of the PC, if that makes sense. But that's mostly applicable to some of the older predecessor scanners that we had. So you may have an HE Ultra out there or an IQ 44 that you might be using. And those you really will start to notice that. And so you get maybe 3 or 4 stops at the very beginning of the document. And then you'll notice instead of the paper running quite as fast as it was, we shift the speed down. And then you get a nice steady data transfer of the image going through the scanner. And again, the advantage to that is the less we can stop the paper, the better. And when you benchmark it, the throughput actually increases because we don't have to back up the original a little bit and go again. So definitely don't see it nearly as much with the new latest and greatest scanners because they're just so fast.
Any of the X series. And so just to back up a little bit, where we were talking about the dedicated black channel, and Dave was saying, would you say that the blacks are denser because of that dedicated channel? So I think that sounds to me like the question of somebody that's been looking at 4K televisions and in intense black settings and things like that.
Yeah, the more ability that you have in 16 bits, you have a lot more. The biggest area that you really notice it in is the ability for the scanner to gradually transition from, say, pure black to pure white, because you have so many more steps of data that you can choose from, that the scanner can choose from when capturing that information. But it is just able to see much greater depth. And in some cases, for example, especially when we talk to black, most originals, when you look at it, your eye, the human brain says, yep, that's a white piece of paper and I have black text on it. And that text means it's black. The reality is that text is rarely, if ever, black. It's usually some version of gray that's less than pure black, meaning it has a RGB value of 0 or a gray tone value of 0. It's somewhere up in a gray spectrum, sometimes 20, 30 steps above that. And so when you scan it and you see it on a screen, you go, wow, that doesn't look very black. It looks gray. And that's because it is gray. However, we have a utility, a filter in Nextimage called black and white point settings, where you can just say, I know it's less than black because it really is, but I want to adjust my black level up. So everything maybe below a value of 20 in gray tone is converted to pure black or a value of 0. And what that does is it really crispens up the original and makes it very appealing. Just like Jerry's analogy to 4K monitors or TVs, that it's all about how black is the black these days. And
you don't have any of that blooming off of it and things like that.
Yeah. So you can take that piece of newsprint or text or whatnot, and all of those characters now are pure jet black. And the white is pure white. It really makes a huge difference. And it's just a simple filter setting, black and white.
And then to jump back forward a little bit, I think Phil Hassel was weighing in on what Doyle had been saying. And he's saying with the speed specs that they also have the benefits of the XDTR, the extended data transfer rate.
I'm sorry, say that again, Jerry.
So sorry, we were jumping back to jumping ahead to kind of what Doyle was saying after you had answered him about the USB 2 to gigabit to USB 3 sort of speeds. Phil Hassel had weighed in and said that with the speed specs of the scanner that they're having, I believe he's saying that they're having the benefits of this extended data transfer rate speeds and things like that.
Gotcha. Yeah. The best thing that we did with these scanners is we added V3 and a very large buffer. That's really where the magic happens. And if you can get an entire scan finished and sitting in the buffer on the scanner, we can transfer that. We can flush that buffer pretty fast to the computer.
And I think that technology we've always touted as our XDTR, right? Our extended data transfer rate. So even when that was with USB 2 and some of our older scanners, we were able to push that data faster than than things were being transferred, or we could really optimize it.
Yeah, XDTR was a patent that we developed around restructuring data sets to be most efficiently transferred via streaming. And back in the older models, XDTR was really critical because
There's
it
no
allowed
onboard
us
memory
to
on the
use
scanner.
Ethernet, which was very efficient at streaming and get the data to the computer even faster than normal. So if you compared our Ethernet throughput versus, say, a competitor scanner Ethernet throughput, we were always coming out ahead. And the reason is because of XDTR.
Gotcha.
And then XDTR2 came later in the game. And so we're still utilizing that. We basically just recompile the data in a manner that allows us to stream it very efficiently.
And I think in the older models, it's most important because there was no onboard memory on those scanners. So it's really relying entirely on the memory of the computer connected to the scanner to process any of that data coming through. So that's correct?
Yeah, the onboard buffers were very small in comparison to what we use today. And the buffers filled very quickly so that we had to do something. We had to stop the scan.
Gotcha.
And then slow the scan speed down to match the computer.
And our next question, so they're saying most of the time we need to set a specific size to scan, such as 24 by 36. And they're saying many times the sheet will end up as a 36 by 120. Why is that? Or if it was a 36 by 24 and then it ends up as a 36 by 120. Why is that?
I can think of a couple of reasons. It probably needs more data and some more investigation, but I'm going to give you if you had a 24-inch document that was coming out 120 and you were auto sizing, there's a high probability, depending on the scanner, that your exit paper sensor may have become dirty or is having a fault. So when we start an original running through the scanner, there's an exit paper sensor that detects where the end of the document was. If we're not seeing that, we're just going to continue to scan until the sensor thinks that it's run out. And that could be a possibility here.
Okay.
So what I would suggest in that particular case, start with the simple things first. Let's go clean the paper sensors. You may need to get a service provider involved to take a look at, we have some test utilities that we can run on the sensors to verify their condition and how they're working. So it might be a sensor that is starting to fail or something like that. A workaround for that would be to, instead of auto sizing, if you're
Right.
scanning 36 by 24, pick a fixed sheet size.
Is that it?
There's two advantages to that. One, often when you scan a 24 by 36, it's very appealing when you're all said and done to have an exactly 24 by 36 original, scanned image. That when you bring the properties up, it says the boundary is 24 by 36. That's very uncommon, to be honest with you, if you're fully auto sizing. And the reason is, it's very rare to find an exact, precise 24 by 36 inch document, especially if paper expands and contracts so much based on humidity that the paper may be quite bigger than 24 by 36, but definitely not 120 inches. That would be pretty phenomenal.
That sounds like a runaway train. And Doyle, were you adding in?
Yeah, a couple of thoughts. Check the resize. If you're setting this to 36 by 24 and you're getting 120 inches, that's exactly 5 times the length that you should be getting. I would check my resize area in Nextimage to make sure that has not been changed, that it's set to 100%. The other thing is I would check my paper sizes.
Right.
I would try that with those turned completely off so it's not trying to snap to an engineering or an architectural size and somehow it's getting confused there. But I would definitely check if you're forcing it to 36 by 24 and you're getting the 120 length, I would start with the resize option if the sensors look good.
Okay.
Yeah,
David,
I think one of the things that kind of leads me to think something else is going on hardware wise is it mentions many times the sheet will end up. I just pulled the question up that had come in earlier. And if it wasn't consistently always 120 inches, then it probably isn't a software setting. But that was a really good point, Doyle, because the resize, you can do it in both percentage, so you could scale the whole thing up 500%, or you can scale just an axis within, or set a axis dimension for resize. So that definitely is something you should look at, but it should do it consistently. Unless, of course, here's another one that happens. You're using presets and you accidentally saved a resize into a preset, and then you picked a different preset and now something different happened. So always go and recheck those settings just in case when you get something odd happening like this.
And David Doolittle's weighing in on this, and this may have actually been his original question, but he's saying that, and I think he's going along with almost what your answer to do in the meantime was, Dan, but he's saying that they have an IQ Quattro. The user has to manually set the page size. The scanner will not automatically detect the page size. It will either cut off the edge of the document or expand. Software and firmware are up to date, and it's random.
Yeah, with the fact that it's random and whatnot, that really starts to point to sensor. Yeah, as the sensors, I'm not sure how old the scanner is, but as they start to age, they typically become less sensitive. And even things like how the sensor's positioned, if it's not exactly perpendicular to the paper, when a sensor is brand new, it's robust enough to compensate for that angular irregularity. But then as it ages, it has less ability to compensate for that. And you'll start ending up with, it just doesn't detect. I would imagine it would have to be a trailing edge sensor, not like leading edge. You would have difficulty getting the document to load or see the front end, and so on and so forth. The other thing that it's not in these large inaccuracies like you're describing here, but if it's smaller, or let's say you have an original and it's cutting off one portion of the bottom, really look at when you're using auto size, the algorithms that do that are very susceptible to things like skewing of the document. So if you're not getting the document in square, we only allow just a few degrees of error there before it starts to
search for another size.
The size of the original, because the paper sensor says, hey, this is the end of the document, but we still have maybe a half of an inch of the document that still needs to be scanned because it hasn't reached, it's way off to the right or to the left side, and it hasn't reached the sensors on where we're capturing the data. So you end up with these cutoffs and whatnot. And so if you have that type of problem and it's just a small amount, really look at how ortho the document is, even in the image, and that kind of gives you a clue. Oh, okay, the operator's not really being cautious when he puts it in. He's getting them in crooked or whatnot. And
one thing that will cause the cropping is you're talking about it being random. If you've got any types of tears or cutouts on the front end of that document at the corners, when it's doing the shoe shine at the front end with the Quattro to sense the width, if one of those corners is torn or missing a piece, it's going to read that as being too narrow. And it thinks that's the outside of the document and will crop it. What we see a lot in the service bureaus is the operators will save a 36 by 24 preset. So if they have to scan wider than the original, and they want to crop that back to 3624 without having to pull those in, they can just reach up and grab the preset for 36 by 24. It'll give you a floating 36 by 24 block that you can just take the little circle, place it over the image where you want it, and hit update, and it'll crop it to a perfect 36 by 24. And if you scan the width of the document or the width of the scanner, it's an easy way to bring it back in. Some of these documents that are in these service bureaus are so beat up and tattered on the edges, it's really tough to sample that document and get the width correct.
And yeah, David Doolittle is weighing back in and saying it's cutting off the sides and not the length.
Yeah, so when it cuts sides, there's a couple of things that can cause that as well. Just like Doyle mentioned, that's definitely one of them. Often with auto sizing, if it is cutting it narrower than it should be, you can end up with some dirt on the glass. And basically what that dirt does, the algorithm that we use to auto size with on an IQ I'm going to be very specific because it's different with an HD Ultra. The IQ uses gray tone comparison as it analyzes trying to figure out where the edges of the sheet are. And that's why it gets a little sketchy if the edges of the sheet are all tore up, because it has so much random information and it's trying to figure out where is the edge of the sheet and where isn't. But let's say you have 2 inches in, you have a real nasty dirt spot on the glass. The algorithm looks at that dirt and it goes, oh, look at this very nice defined line running through the original from very beginning to the very end. I think that's the edge of the paper. And then it cuts it there. And then you end up with a document that's missing a couple of inches. And it's just the opposite if it's cutting it too wide. When it cuts it too wide, it could be something like that on the glass, or if it's a roll-fed scanner, possibly out on the white background plate, where it sees it consistently, so it assumes that the edge of the paper, because of this nice gray tone defined line, is way out there. So anytime you're auto sizing incorrectly, too narrow, too wide, first go-to is go to the glass and really start looking close at it, because you probably have something on it, like some glue or that type of thing.
And that may actually lead to what could be our last question here, which is when scanning documents with the border near the edge, it sometimes cuts off part of the border. How can I resolve this?
Yeah, same analogy, and it could be a combination of all of those factors.
Because that seems, when it cuts off the edge, it's usually because it's skewing and it was close to the edge and it's clipping a bit of that.
Yeah. So there are some tricks. Like one thing that I have seen some people do is maybe they'll just scan oversize, where they're actually scanning, if it's a 36-inch document, maybe they scan 37 or 38 inches and just give it a boundary. And then Doyle's trick of taking resize crop and superimposing that 24 by 36 perfect as a post scan feature so you scan original, you drag over the template for 24 by 36 and click save, and boom, it gives you this nice cropped area. That's a solution. The other thing that you can do, let's say it's consistent. This is another thing that can happen. If it's consistently adding maybe 3/8 of an inch or consistently cutting 3/8 of an inch off at the top or the bottom of the original, we also have paper handling borders setting in Nextimage that you can just add some extra scan to the end of the document. And that will prevent that from happening. Because again, we're using paper sensors, and if your paper sensor is just not quite detecting that paper exactly at the end, and honestly, most of the time that happens is because it's a curled or a rattery, tattered type original, and it's just having a hard time catching exactly where the edge end of the paper is. So oversizing a little bit and then going in and adjusting that post scan, and or just using, that's just what I said, use this other template that you're going to take over the top and crop it. Often in a high production environment, and Doyle, again, you're the expert even more than I am on this, I think you'll find in a lot of locations, you're going to have scanner operators that are really good at getting throughput through the scanner. And often what they will do is they'll have these high-end operators that are used to running a scanner and getting scans created quickly. You'll have that operator. And then they'll have, say, a post scan operator that is taking the files off of a server somewhere, bringing them up, cropping them, maybe adding metadata information, that type of thing, and getting it exactly to the specification that their customer is requiring, and as a post scan process. And they can do that pretty fast and efficient as well, because that's, again, it's very repetitive in its nature. And I don't know, hopefully that answered.
So just a comment, there's a phenomenon that's been popping up, probably, I've seen it for maybe 6 months now. And in the past, when you saw inkjet prints or you saw things that were drawn on the board, you had margins around your border where you had decent amount of white space for the most part. Occasionally you would get an old blueprint that, or something along those lines, was run through, misaligned, and a border was off. But what is happening and we're seeing it a lot in half-size sets now that are being run on laser printers. We're literally not even getting a 16th of an inch between the border and the paper. So the auto sizing portion of it is challenged, to say the least, when they're looking at a grayscale count for a spike, because there's just not much space there with the white. If there's any skew, it doesn't take much. Then basically, and you've got the auto alignment turned on, it's going to lend itself to slicing that border either on the bottom or on the sides. And that's where depending on how the service bureaus are doing it, they're looking at it in a way that a second set of eyes is going to go on it for a QC process. So they've taken their operators basically, and they're using them and the scanner to create the data. They're just gathering the data. They know it's scanning wider, they know it's scanning longer, but that operator's got a visual that basically says, I got everything on the side, I got everything. I know it's not chopped at the bottom. So if something was run in a way that bottom border was sliced when it was printed by the laser printer, then they're actually seeing white space below, so they know. And what they're doing, they're smart enough to get the preset set up. And the dirty little secret that nobody talks about with Nextimage, which should be the number one selling point, is the end user license agreement allows you to put as many versions of Nextimage on your computers for QC purposes as you want to, as long as you're only running one Contex scanner. So you could have literally one scanner operating at tremendous speeds, gathering this, and then from a QC 100% assurance standpoint, you could have one or more operators dressing those files up to sell them, to get them out the door, have them sized so that they could be literally be putting filters on them at that point to take it from grayscale to adaptive thresholding. As long as you don't go to a pure black and white file, you can adjust that file in Nextimage from a post-processing standpoint. You can do anything to that file that you could do while you were scanning,
and even a little more
away from the scanner.
And that brings up
Go ahead,
Sorry,
Jerry.
Doyle, didn't mean to interrupt you.
No, it's okay. The only reason you should really have a rescan, which is the scourge of every service bureau, the number one enemy of production, is the rescans and having to pull something to scan it again. If you crop it, or if you allow a dirt line basically to go through the drawing that you can't take out. Anything else that you would adjust when you were looking at it on the screen, you can do it away from the scanner.
And that brings up a great point with the file mode in Nextimage. That is some incredible, powerful software to work on, especially large format images, even if they didn't come from our scanner. I think that's one of the best tools I've ever used to simply create blow-ups of smaller photos that I want to have printed out, poster size and things like that, without that pixelation that you see when you typically just enlarge an image. Because one of the things Nextimage does when it resizes it, it also resamples that image at the same time. So all you have to do is give it a size and it does all the work along the way. And that's a really great tool to use for not just running the scanner. And that file mode's included in all versions of our Nextimage software. I think yep.
One last point with auto sizing. If you have an HD Ultra X, on that particular scanner, we added a bunch of extra paper width sensors in the scanner. And the advantage to that is, based on how many sensors are covered, we can very accurately determine if this is a standard paper sheet size or not. And then you can snap the image to the closest known paper size for that series. And it does a lot of this for you. The only thing you have to be cautious again with that is skewing, and that type of thing can throw that off. And but basically it does it automatically for you. You don't have to be as precise when you're inserting a document right or left, because it knows if 5 sensors are closed, then this has to be within this series of standard sheet sizes. And then if you're scanning to, say, ANSI or architectural, it will snap it to that, whichever one that you have enabled in your snap to paper series. And so there's some really nice features with those extra paper sensors that were added. And but those are only available on the HE Ultra X.
Sure. And so we're past our hour. And so we'll go ahead, unless we have any other questions, I think we'll go ahead and wrap things up. And thank you very much to our experts, Doyle Cryer and Dan Bennett. And of course, to anyone that sent in some questions, and please keep them coming. We'll make sure and include them for next time. And we look forward to seeing everyone here for our next Ask the Experts Q&A session, as well as maybe we've got some other Contex webinars coming up soon. So great. We'll go ahead and end it. And thank you all for coming today.
And super quick, Jerry, before you hang up,
Sure.
A shout out to guys like Phil, he's our distributor in the UK. So we have some international customers here as well. And if you're a customer from outside of the US, we drove this webinar out of the US, but if you're in a different country and you're looking for a distributor in your local country, please go to Contex and click on the distributor lookup and put your country in, and that'll get you connected with the experts in your local area as well.
Yes, and sorry to mention that Phil Hassel from Allied Images, they're a great distributor for Contex in the UK.
All right, guys.
All right, thank you all for coming. We'll see you soon.